graph databases are different. Now, since they store the information in form of nodes and relationships, they are able to extract all, I will say, more insights from a data rather than, say, a traditional database as well. And this gives them a capability to even build a very scalable graph rectangle of a pipeline, which is able to extract the information in a more up-to-date and I will say context-aware fashion. So that's a very brief about it, but we will see it in our next slide. So this is something that I wanted to talk about. How is the vector RAG? I think we have already discussed this in an earlier session, but it starts from a user query, and user query acts as an input, and you can give any document that you may like. And LLM, because it has its limitations in terms of training data, right? Your document may, and data within that document may not be available as part of your training data of LLM. So what it does is, it searches the external sources like vector databases, and then it retrieves the information from those external sources, and it chunks those documents into several chunks. Now, the question is that why it splits into chunks, because initially, LLMs used to have this limited context window capability. Now we have many LLMs which has many million tokens as part of its context window, but that's another thing. When we split these documents into chunks, and once we have these documents split into chunks, we have this embeddings created on top of these chunks using any embedding model that you may like. And once so that's the generation part. And when you come into retrieval part of it, LLM will take all these information that has been retrieved from these chunks, rank it with the similarity search that it will do in those vector databases, and then using a combination of those initial user query and the context provided by this similarity search, and which is also ranked, it will basically give you the output. Graph RAG, as I mentioned, many people even call it knowledge graph-based RAG. Many people call it graph RAG. You may call it in whatever name, but it basically, the only difference between a vector RAG and a graph RAG is on a retrieval part. So when it retrieves the data, it retrieves the data from knowledge graphs instead of the vector databases. That's the difference. And because it retrieves the data from knowledge graph, it is able to extract all those insights, all those probably information which your traditional RAG may have ignored or may have not been able to capture. So graph RAG is in a way an improvisation on your traditional RAG, because it fetches during retrieval, it uses the knowledge graph. And that is the reason why, if you see, leveraging knowledge graphs as part of your RAG pipeline, the responses given by LLMs are usually more better in quality compared to your RAG pipeline. But yeah, we do have another type of RAG, which is hybrid RAG, which combines the strengths of both the vector as well as graph RAG. And they are actually even a step ahead, even compared to graph RAGs as well. But that is not the scope of this speech. We will probably discuss hybrid RAG, and it needs a lot of time to discuss about it as well. But graph RAG, as I said, it leverages knowledge graphs in your retrieval, and the outputs then given by LLMs are usually more context-worthy, and it is a step ahead compared to your plain vanilla traditional RAG. Now coming to AgenticRAG, okay? Now I will just say, when you think about AgenticRAG, you need to think about, how can you summarize multiple documents? How can you, for example, compare different documents that you may have? And if I want to do it in a very orchestrated way, that's how you call this as an AgenticRAG. Now, you start, I mean, in even AgenticRAG, you start with a user question. And below, if you see at the lower level, we have document agents, which may summarize each of those individual documents. And then you have a ranker and a very top level agent, which actually manages those individual document agents. So it's being done in a very orchestrated way. And it's like, think about chatting with your multiple documents in a very orchestrated fashion. So that's how we, that's basically the principles behind the AgenticRAG and how we basically, so I'll just give you a scenario. Suppose if I have to do any investment, and if I use AgenticRAG, it can search multiple sources. It can even not only search, but even come up with the information which is, very specific to my investment that I'm making. And then it can even rank it as well. And then using the ranking of those priority documents, it can then show me the output that, based on your query, which is the most preferred investment that you need to go to, considering your tenure and considering the various other limitations that we may have. So think about it as agents which are basically helping you to in a decision making. And if you see in this, we don't use LLMs. We have agents which basically may conversate with each other, or it can even you may even have one agent, or you may even have multiple agents, depending upon how complex your use case is. So this is the architecture of the AgenticRAG. If you have to build in a very scalable fashion, and as I said in an earlier slide, you start with a user query, and the agents has a capability to transform those queries and to even route those queries to specific external sources. Like it can search within the databases. It can even do a search via API calls. It can even search a document store that you may have. So it has a capability to search wide range of sources. It can even have a capability to transform your query. And then it uses this ranking based on all those that has been retrieved. And using LLMs, it is able to then give you the output by combining all these into one. And then if you see the output that is given by this AgenticRAG is far more worthy and far more context aware compared to even the earlier scenarios that we saw, like GraphRAG and even VectorRAG. So one of our use cases that we often use AgenticRAG is, as I said in an earlier slide as well, is the intelligent retrieval. So whenever, so one of the use cases which I can think of is, suppose you can use AgenticRAG even in an e-commerce application. And suppose if user types in that I have to buy GPU-enabled 16 GB laptop. So it can do a keyword search for you. It can even do the document search for you. It can even traverse through catalogs which can have those information, have that keywords, and then it can even compare those documents and probably provide you with the one which is providing the specification of a laptop that you gave in a more economical way. So it has those capabilities of doing the dynamic research, traversing through different sources, and even ranking them as well. And another thing that if you see over here, which I just talked about earlier as well. You can even use it for for example, in your investments as well, where you are just, it doesn't only pull the data from any random sources, but it is basically trying the data from various sources and then giving you the very relevant information, and which can help you to take a decision accordingly. Another scenario which we have, is multi-agent orchestration. So as I said earlier, that depending on the use cases, you may even just have one agent, or you may even have multiple agents conversating with each other and providing you with the better information. For example, if you see this use case, you may ask, like, what are the environmental impacts of selecting EV over the traditional fossil fuel enabled cars. And so you may have in this architecture one agent which is just going to gather the environmental data, and other agent which is just going to probably discuss and traverse the information about the benefits of those multiple cars, electric cars which are there in the market. So it's even possible that in your use case, you have multiple agents, and each of those agents will be doing multiple jobs. And then combining those agents, you can even get the answer which is more relevant to you. So it depends upon the use case. It depends upon how your use case is simpler or complex. And based on that, we can even have multi-agents orchestration scenarios, which basically utilizes multiple agents and gives you the final output, which is probably traversing through multiple sources, multiple agents, and even the multiple ranking systems as well. I think this is another thing that I wanted to show, which is a key difference between traditional RAG and the AgenticRAG. First is based on a primary functionality. If you see the primary functionality of any traditional RAG, it's just to basically give you the sources from it just generates the text from external sources. But if you look at the AgenticRAG, the primary function of the AgenticRAG is it will traverse, it will sense, it will reason, and it will even acquire knowledge from external sources. And based on that, it will probably give you the answer. And again, it is needless to say, it is used more in more complex scenarios compared to a regular RAG. And one of the key features of AgenticRAG is dynamic learning. It's keep on updating its knowledge base. It doesn't rely on the static knowledge base. So, and because of this dynamic learning, it can, evolve its learning base over a period of time. And that's why the queries or the user query that you give, you will find that the answers to it are more real time and more on the latest happenings than compared to a traditional RAG. Because you in a traditional RAG, you have a periodic updates and retraining, and which are actually done over a period of time, not regularly. But in AgenticRAG, you have this dynamic learning, which can, leverage the real-time scenarios that may have happened. Any questions till now before we actually move to implementation of part of it? Yeah. So even when you set the rules, you can even evolve those rules over a period of time. It doesn't necessarily mean that the rules that you have given are the only source of it to give you the data. It can even evolve. It's like, for example, I'll give you an example. Suppose the example that I gave about the e-commerce application, right? Where you can probably searching for a laptop. It can even search the data from other sources as well, which may not be native to that application, and then rank that, okay? And so it may not be in its rule base, but it can even well cover the other sources, which will help in giving the final output, which is far more better. It can even compare the different sources and give you, okay, probably this laptop that you are looking for probably at X side is more cheaper than here. So it all depends upon how your rules are evolved over a period of time. And if you, e-commerce is obviously a complex scenario. It may even have multiple agents as well. So different agents will have a different rule sets, which probably be a complementary in nature. Yeah. Any further questions before we actually move to demo part of it? Sure. No, so one of the things that you probably see here is how complex. Yeah. So one of our questions that we have been asked over here is that when do we decide that for a given use case we have to use the AgenticRAG? Is there any threshold or on what criteria do we decide it? Okay. I will say it depends upon use case to use case. Suppose if I have to, if I'm working on a use case which is just extracting data from unstructured documents, probably I will even go for a traditional RAG as well. Okay. But suppose if I have to make a decision which is probably, and that decision may be of more importance to my CHO, okay, then probably I will probably use agents, because I know that if I'm using agents, they have a capability to even have this dynamic learning over a period of time. It can give me a real-time information. So it depends upon the use case. And I will say that the more complex the use case is, the more probability is that you will probably go for AgenticRAGs.
Cipher query and graph query language both are same, right?
So Cipher query language has been made so that you can, whatever nodes and relations you have in a graph, you can extract that relevant information for you. Like for example, if I have my earnings data of my company stored as a knowledge graph, I can very well write a query which fetches, say, information about what was my earnings of this period. Okay, it's very similar to your SQL. Okay, like how we do select from this period, where it's very similar. It's just that the syntaxes are different, but in that you're probably, when you're writing a SQL query, you are querying against the information that is there in a database. When you're writing a Cipher query, you are searching against a knowledge graph. That is the difference.
But okay, my question was GraphQL and Cipher both are same, right?
Yeah. It's basically a language which you use to get the relevant parts of your graph.
Okay, I understand this. When you do a Cipher query, it's like a sequential operation. If you have a very big graph, it has to go and search in different part of the graph. But in Agentic, you can do it parallelly. Is that correct?
You can do it in parallelly.
Yeah,
and that is the why, if you see many of the use cases and even evaluation metrics that we have RAGs as for RAG pipelines, agented RAGs in many metrics, they rank higher than even the graph RAGs as well. Yeah. So not in perspective of latency, but for example, faithfulness of answer is also one of the metric that they use. Okay. So this, and depending upon the metric, depending upon the answer which is most relevant to you. For example, your business may be more concerned about the faithfulness of answer rather than your answer being very generic. Okay. You would have seen many chatbots which give you very generic answers. Okay. And they may be utilizing, for example, a naive RAG pipeline. But if you are getting the answers which are very relevant to your query and gives you very precise answers, probably the pipeline structure that they are using behind the scenes is actually agentic. Okay. Yeah. Yeah, exactly. So I'm probably moving forward and having a show you the implementation of one of the implementations of AgenticRAG, how it is done. So just give me 1 minute. So if you see this, so this is a simple notebook that I have just prepared. And if you see this pipeline that I have made, you can so this entire notebook will use llama pass. Now, what is llama pass? Llama pass is basically probably a library which you can use to traverse many PDF documents. Okay. And once you have passed your documents, you have an ingestion pipeline, which basically will cache those documents, cache your information, which is important, and even have the embeddings created out of those. And then using those embeddings, we have a React agent here, which utilizes those information which are stored as part of our embeddings. It will also use the web, which is external source for its information, and then retrieve you the data which is most relevant based on the query that you have given. Okay. And in this notebook also, I'm using Llama Index. So feel free to install it before you actually implement it. So if you see over here, I'm just installing all the Llama Index specific dependencies. And then once I have done that, I'll just download the data. I'll ingest the PDF document. So as I said, you can ingest multiple PDF documents, or you can even ingest one PDF document based on your use case. So in this example, I have just given a one PDF document, which is basically a car manual. So this is a manual of one of the models of Chevrolet, which has been given as part of an input to this agent. And this is just a one document that I have given. And this is, and I'm using Redis. And why I'm using Redis is because Redis provides you the vector store. It can even also provide you with the caching capabilities, and it can act as a very important pipeline component of your ingestion pipeline, because the ingestion pipeline that I just showed you earlier, if you see, it uses the Redis cache, it uses the Redis document store, and it is even using the Redis vector store as well, where all your information that you have given as part of your documents are stored in a vectorized form. So once you have given the documents, once you have installed all those necessary dependencies, and once you have even set your host, ports, and everything, I mean, from a configuration perspective, once you are set in, you can just simply pass your document. Obviously, needless to say, you will need your API key for Llama as well as for Cohere API. And once you have given all those API keys and a configuration, you can just simply pass your document. And so you see here, I'm using Llama Pass over here, which is basically, since I'm using Llama Cloud, it's a very efficient way of passing your PDF document. And once it is done, I'm even building my own custom schema using Redis Vector Store. So it will use the embedding model given by Cohere. And we can also have some custom index specifications on top of that. So for example, if you see over here, I'm not only using the Redis vector store, I'm even specifying the embedding model that I'm going to use. And on top of that, I'm even specifying the custom schema that I'm probably expect the structure in which I want to have an evenly response. So this is how I've given the Llama index and a Redis vector store. And this is just the very brief about the architecture, which I even showed you previously, where you have all these documents using Llama Pass. You have an ingestion pipeline, which is utilizing the Redis vector store and an embedding model given by Cohere. And then once you have this ingestion pipeline, if you see all things you are being specifying as part of your parameters. For example, you are specifying embedding model as part of your parameters. You are even specifying what is your host, port, and everything else. And as part of your Redis vector store, you're even giving the custom schema that I just mentioned on top of here. So it's basically telling or instructing your vector so that this is the schema which I probably want you to adhere to, and this is the URL on which you will have this hosted. And then you can even utilize the, as I said, you can even utilize the Redis cache, which basically will cache all the important information which you may like from a document. Right? Consider, for example, if I have to, you know, have some FAQs as part of my documents, I can very well have those FAQs cached as part of a Redis cache as well. So once we have done all the configurations of my ingestion pipeline, the only step that remains is to activate the agent. So here I'm using the React agent, which will basically do the three things. One, it will decide whether to use the which query engine tool it may have to use, and then based on that decision, it will also give you the response considering all the output given by the ingestion pipeline, the embedding model, as well as the LLMs. So here, if you see, this is a step that I'm doing to set up my agent, where basically, I'm setting up the cohort as part of my embedding model. I'm using command R plus as a model given by the DEMS itself. And then I'm even setting up the what all memory configurations I need to build in. For example, there's a token limit that I have specified over here. And I also have specified which URL my application will be hosted and how many users will have this. So all these configurations related to your pipeline, you can very well configure over here. And this is just a function which is actually building that agent which basically runs the ingestion pipelines. It will even pass through all the nodes, and based on those vector indexes that it has formed, it will summarize all those information which has been captured as part of an ingestion pipeline. And then it using different tools, it will give you, any specific answer to your query. Now, for example, we have seen that we have given an input of a car manual, which was a specific model of a Chevrolet, and I can very well use and ask any question which is probably specific to that model. Now, there may be some queries that you may ask which may not be as part in manual, but it may very well try to answer that based on the web sources as well. So, so here, if you see, you can specify all your configurations, like which LLM you're using, what's the memory, and what is the content, and you're even giving the context over here. Okay, and once it's done, you can very well activate the agent and ask whatever questions you may like. For example, one of our questions that I have asked over here is what is the seating capacity of a vehicle? Now, usually you will observe that the seating capacity of the vehicle, so many times it's mentioned or many times it's not even mentioned in the manual, because in the manual they focus more on the configuration part of it. So sometimes it's not even mentioned as part of a manual. So if you see over here, there has been a calls to fetch this information. So you see here, it recognizes the input that I have given, and based on that, it makes the multiple calls. It fetches the chunks which has this information. For example, if you see over here, it identified that there are some chunks which may have this information, okay? And but those chunks that has been retrieved didn't had the answer to my specific question, which is what is the seating capacity of this vehicle? And that's why it told me that, based on a source that you have given, I'm not able to find this answer as part of a manual. So, but if I ask any further questions to it, like for example, what is the towing capacity of the vehicle, which is generally mentioned in the source, or manuals. So you are able to see that based on this query, it has been able to retrieve what's the towing capacity of the vehicle and what's the configuration of it in a very detailed way. Um, so, and as I said, that you can um, activate the web sources. So whatever information that is there in the source, it will try to cover, but even it will try to search for the web sources and whatever relevant information it gets specific to your query, it will even get answered by that as well. But in this agent that I have created, I probably kept it as off because of the cost constraints. So if you see that most of the questions that I have asked specific to the vehicle have been answered by the agent, and the answer is actually a very detailed one as well. So I don't need to read the entire manual. Whatever questions that I may have before purchasing the vehicle, I can very well interact with the agent. I can get those questions answered from it rather than reading the entire manual, which may be very lengthy. So for example, this manual is probably how much? 24 pages. So I don't need to read those, and whatever questions that may have, I can just query and get the reply. And so if you see even the most generic answer or most generic question, like what's the pros and cons of this vehicle, is also answered. Though it's not covered in a manual, but still it's still able to answer that. So if you see over here, it's able to answer what are the pros and cons of this vehicle, and based on that, you can take that a decision whether you have to go ahead with the vehicle purchase or not. And as I said, this is just a notebook. You can very well use LangGraph to build a very complex agents which can even traverse different sources, which I think we saw in our earlier session as well. This is a very simple notebook. We're utilizing Redis, utilizing Cohere, and we have been able to just give one manual and get the information out of that. But even in this notebook, we are able to see that it does a pretty decent job of getting all the answers that I mean, getting the answers for all the questions that I have asked. And also it can, as I said, that all the information that it provides, you can very well cache it as well. So whatever queries, whatever answers has been provided can even be available as part of your cache or documents too. And on top of that, I've even incorporated semantic caching. So can someone tell me how semantic caching differs from your normal cache that you have? Or normal caching techniques? Yeah, it's partially right, I will say, because when you use semantic cache, you are even storing so whatever answer you get as a part of a query, it stores even a metadata associated with it, okay? And then based on that entire structure, even a metadata is stored, and then it's stored in a cache. So it's like, it's not a keyword-based cache that you do in a very traditional way, but it's like having the queries results stored along with its metadata. So when it searches, it can very well relate to those semantic cache and retrieve the information accordingly. So that's a step ahead compared to the other caching techniques that you have. So you can even very well have those semantic cache implemented, and even for example, and as I said earlier, that mostly we use caching for very frequently answered questions if you want. So all your FAQs can be simply cached. So you save on the tokens, you save on the cost. Yeah. And you can very well define the thresholds as well on based on what similarity beyond that it will cache it. So yeah. So if you see now, once I've implemented semantic cache, you can also ask how many doors does this truck have, and it can very well retrieve it and say, yeah, photos and how many passengers those are on there on a truck. So the entire intention behind implementing semantic cache is that all your important information can very well be stored in form of along with the metadata. So you save on the tokens, you save on the cost associated with your LLM calls. So, so this is a very simple notebook which basically showed us how you can how can you design your agents to get the information specific to your documents in a very real-time, context-worthy way. Before we move forward to another demo, do we have any questions specific to this before we move forward? Yeah. Yeah.
Hi. So I've seen that you've given the agent mostly related to text, and your document also has images.
Yeah.
So if we were to use LLM graphs, LL graphs, does images? How does the image chunking happen?
So image chunking is not that straightforward as you know, because most of our documents that we usually pass is in a form of text. But if you have a lot of tables and images as part of your document, we need to have one additional layer, which basically will be able to retrieve all those. Like basically in LangChain, we have a different loaders. Okay, for example, you have a web-based loaders. You can even have an unstructured loader which can very well get all those information from a tables and images which are there in a PDF itself. So it's a combination of loaders that you need to employ. So if you see in this example also, I just use LlamaPass, but if I have to retrieve information apart from from tables and from images, I'll probably have to use LlamaPass in combination with different loaders of LangChain to even get that information. So it'll be a combination of loaders rather than just having a LlamaPass. To your question,
Much.
yeah.
Yeah, so I'm actually trying to understand the concept of dynamic when you say, right, that agentic RAG actually gives that dynamic prompt which
Dynamic
you were saying.
learning.
Yeah. So can you just tell me a control flow kind of thing? For example, if I ask your RAG pipeline a question give me a comparison of speed of the vehicle which you are showing and the vehicle something like Subaru or something like that, right? So how does the flow, go, and how can you say this is different from basic RAG? So I just want to understand that. I'm pretty
So
much new to agentic RAG.
yeah.
So like,
So
what is the
if
differentiating?
you refer to the architecture that I showed in as part of my AgenticRAG, you would have seen that we have a lot of lower level agents operating, and we have a one top level agent which manages all those lower level agents. For example, in this case, I'm just starting with one document, but in reality, you may be having the comparison of this particular model with several different manufacturers as well. Okay, so it's like interacting with different documents, not a one document, which may be having its own specific agent. Like for example, you may have uh, one document per agent, okay, and which will summarize the content within that particular document, and then you have a one top level agent which will summarize it and give you the answer based on all those summaries it has been able to get from all those lower level agents and rank it as well. So, and then provide you the answer which is specific, most precise and specific to your query. So here, if you see, it's just a one document, but it can even well search the multiple manufacturers, their data, and help you take the more informed decision based on that as well. So as I said, that I have probably kept the web sources as off, but if you enable the web source, you can even well traverse to the different sources and a web search engine calls to give you the competitor pros and cons as well. Yeah. So in real world, we operate with multiple sources. Okay, we don't operate with a single source. And as far as ambiguity is concerned, it's basically how good your summarization is. Okay, it can very well be a thing that I can just give you examples. So for example, the summarization of different models can even be overlapping. Okay, there may be some of our features which are even present in the competitor as well, but it depends upon the eventual ranking of that, and then based on that it will give you the decisions. So what I'm trying to say is that even summarization may be overlapping across different documents, but when it ranks it, okay, then it will give you the most relevant model which has not only the overlapping features but even the additional features which it feels based on documents may be more specific to what you're looking for. Yeah. I think in the interest of time, we'll just have it wrap our session over here. But feel free to contact me or ask any questions if you may have after the session, or even you can connect with me on the LinkedIn as well. Thank you so much for your time.
If you're serious about a career in AI, follow Deep Tech Stars on your favorite social media platforms.